Good morning, everyone. Welcome back. We have a really fun session prepared for you today. It's going to be a little different from what we have had so far, and I think you're just going to love it. So throughout this program, we have really been going deep into quantum optimization, right? But today we are going to take a step back and we're going to ask a broader question. What does the future of quantum actually look like for all of us? With us today, we have Guy Ellis, who is the co-founder and director of Terralon Media, where he creates story-driven content that makes complex ideas accessible and human for wider audiences. He's also the co-director of Our Quantum Future, a feature documentary produced with the Quantum Insider that explores the people, technology, risks, and possibilities shaping the future of quantum computing. Like as scientists and engineers, like we get sometimes like so deep into the technical details that, we forget to take a step back and ask the bigger question. And, that's exactly what Guy's work does. And today we're going to be learning more about that. So we will be watching a screening of our Quantum Future film, followed by a conversation with Guy. So let's sit back and enjoy today's session. Please join me in welcoming Guy Elias. Over to you, Guy.
Thank you very much. It's a pleasure to be here. I'm just going to set up my share and make sure that we're all good. We'll get going. We should be able to see that.
Yep.
Excellent. Okay. Well, thank you very much for having me here. It's a pleasure to be here. To start off, as Abinaya said, my name's Guy Ellis. I'm a co-director of Our Quantum Future alongside Evan Cubas, who is from the Quantum Insider, who is part of the Resonance group of companies. And we made a feature-length documentary about quantum technologies called Our Quantum Future. And what this is a 90-minute documentary exploring for a general audience. Firstly, what is quantum technology, a little bit of an intro to quantum mechanics, all of those kinds of things, with a view to making people have a greater appreciation of what the technology is and what impacts it could have on their lives. So originally, this started life as a UN-backed kind of idea as part of the International Year of Quantum, who came to the Quantum Insider and asked to make a piece of content around it. And then working with Evan and the Quantum Insider, we expanded that remit and got a bit more ambitious with it and made it into a full-length feature exploring the topic. So that's the co-directors, myself and Evan. I'm obviously from a kind of filmmaking background. I'm a co-founder of a production company called Terralon Media. We're based in the UK. And Evan is founder of the Quantum Insider and president of Resonance, who, you've probably come across the Quantum Insider if you're interested in the industry. They're a marketing and data intelligence platform. But really our roles were myself and my team at Terralon. We provided the kind of filmmaking production expertise and creativity, and the Quantum Insider team provided the kind of fact checking, setting up interviews, finding people to feature. So firstly, why this film? And actually one of the things that you might notice is that throughout this, I've actually lifted significant sections of text from the original pitch deck that we made when we were starting to prepare to make this film. So you can see a little bit about how we were thinking about first presenting it and making it. I'm not going to bore you all with the details. Quantum technology, I know a lot of you are very familiar with it. You've been doing deep dive technical sessions. But yeah, the reason that we thought that we should make this film was that unlike some technologies which really steal the spotlight today, like AI and more recently space, quantum is something which in the general public consciousness kind of is currently flying under the radar a little bit, especially given the size of the impact it could have on our society and people's lives. And despite that, there's a very interesting story of companies and states, both big and small, engaged in this kind of competition, certainly when it comes to quantum computing and quantum sensing, to really achieve and demonstrate quantum advantage. And we wanted to make people a bit more aware of it and give them a deeper understanding of what this actually means. Because it's one of those technologies which I think, as we all know, could have a very significant impact on society, and currently much of the general public are unaware of it. Yeah, why now? Again, it's something which is not in the media spotlight. It's not in the general public consciousness very much at the moment. But we are certainly approaching an inflection point looking at the industry where significant funding is going into quantum computing, quantum sensing, other quantum technologies from both companies and states, big and small. And there's really, really interesting kind of competition heating up. You've got the Microsofts of the world, Google, AWS, Fujitsu, etc. On the one hand, the kind of big incumbents, and then you've got China, the US, the UK, European nations, Japan, really pouring resources into this from a state level. So it's kind of one of those stories which is, clearly a lot of very intelligent and very powerful and very wealthy people, companies, and nations are very interested in this. There's got to be a reason why they're betting on quantum, and that's the kind of a really good basis for telling an interesting story. Okay, so the biggest challenge that we faced creatively and in terms of producing this was, how do you explain quantum mechanics, quantum computing, etc., to a general audience? Remember, we're targeting the general public, people who might be interested in, tech and science and kind of future technologies, but these are not PhDs. These are not, many of them won't even be, STEM graduates of any kind. It's just kind of general public, average Joe. And yeah, one of the big challenges was how we introduce the concept of quantum mechanics, because you kind of have to introduce that a little bit before you can get into quantum computing. And how do we tell a little bit of the history so far of quantum mechanics? Because this was a really key part of the documentary, with it being initially started in 2025, which was the kind of 100th anniversary International Year of Quantum of the kind of formalized advent of quantum mechanics. We wanted to capture a little bit of the history of how quantum mechanics came to be, some of the key figures, and the impact it had already had on the world in terms of enabling, it essentially directly leads to the transistor. It leads to, which then eventually leads to, microprocessing. It leads to nuclear capability, both weapons and energy. That's all kind of comes out of that first quantum revolution. So we also thought that was a really interesting historical story. But so as we were grappling with this, we decided that the best way to do this was to introduce some humor and some human moments. And one of the kind of opening montages of the film addresses this, because the word quantum gets thrown around a lot in Hollywood and the media, often inaccurately. So we wanted to kind of address that and give a little nod to it. Our first clip, which hopefully everyone will be able to see here, is about a minute. All of these clips are about a minute. But this is one of our opening montages from the film.
I had to build a functional quantum computer just to crack my own encryption.
Not to mention the quantum physics, which is really something that should be studied here.
Quantum phase is when an object moves through different states of matter.
The colonist command center had like a quantum flux power reactor.
The doorway into the quantum realm was opened.
Not like we're talking quantum physics here.
I think the science part of your brain would enjoy it.
I'm interested in science.
It's quantum entanglement between the quantum states of Posner molecules in your brains.
This quantum physics is confusing.
Could we modify a quantum spectrometer and track it?
Do you guys just put the word quantum in front of everything?
How much do you know about quantum mechanics?
I'll bet any quantum mechanic in the service would give the rest of his life for a chance to fool around with this gadget.
That's some quantum shit right there, man.
Quantum physics.
Simple quantum mechanics.
And I'm not gonna listen to any more of your capitalistic, quantum, friggin' dumb, limbo, mumbo jumbo.
So that's kind of a couple of minutes into the film. We kind of try and address that key issue, and with a little bit of humor, a little bit of so a few recognizable clips in there that people will, associate with quantum. As I said, it's used as a crutch a lot in Hollywood film making and storytelling. And by the way, I forgot to say at the beginning of this, I can take questions kind of throughout this. So please do submit questions on Discord, and I'll do some pauses throughout. There'll be an opportunity for me to answer some of those questions as we go. So yeah, feel free to submit any questions on Discord that come up as we're going along, and I'll see if I can address those. But yeah, bringing complexity to a general audience. As I said, that was kind of our biggest challenge with making this film. I've worked in kind of alongside quantum for a while now. I've been working with the Quantum Insider, making promotions and company profiles and things like that for several years. So I kind of have an introduction to quantum, how it's communicated, how people talk about qubits, how people talk about the kind of the thing that their company is doing, etc., how they try and communicate that to investors, etc. But it's very easy when you're deep in this field, especially if you've got a very deep academic background, which I don't in this, but even so, it's very easy to end up presenting a kind of impenetrable wall of science to someone who asks about what is quantum computing, what is quantum mechanics. And we really wanted to grip that issue and try and make it accessible, try and make it fun, try and make it human, but also at the same time maintain credibility. You get a lot of, we've all heard, I'm sure, many analogies for how qubits work, for what quantum mechanics is, what superposition is, etc. And many of them fall a little bit short, especially if you've got a deep academic background in this. So I'm not saying that it didn't entirely manage to avoid falling into some of those traps, but we tried very hard to maintain a level of scientific rigor and academic credibility with how we explain these concepts, whilst also still allowing them to be entertaining and successful and accessible. We leaned on two key pillars to do that. Firstly, we interviewed some fantastic speakers. We've got 3 Nobel laureate physicists in the documentary who we lean on heavily to help explain the origins of quantum mechanics. So we've got Bill Phillips, we've got Eric Cornell, and we've got Alana Spey, all of whom Nobel laureates with great depth of academic knowledge and credentials in their own right. They were kind of our main quantum mechanics kind of storytellers, as it were. They're very good communicators, and they were kind enough to lend some of their academic credentials to us to help tell this story. Alana Spey, of course, is also, now credited, having won the Nobel Prize in 2022 for his 1982 experiment successfully demonstrating entanglement, which is very timely for us. He is one of the kind of godfathers, as it were, of being able to demonstrate spooky action at a distance, a really pivotal moment in the development of quantum mechanics, as you all know. The other thing is, obviously, we decided from a production perspective that we absolutely had to bring in some animation. So we did custom 2D animation to really help explain concepts in a way which people would get. So leaning on both of those was our principal pillar of how we tried to address what is quantum mechanics, all the while being upfront with the audience about the fact that this is complex, it's difficult, and using kind of humor and kind of human moments to really communicate that, so that people know, anyone watching, when they see in this next clip that I'm going to play you, when you see Eric Cornell, who's Nobel laureate, saying he didn't really get much of it at first either, it kind of makes it okay. It's like, right, everyone kind of struggles with this. So it's okay that you, as the audience, the general public, you don't know exactly what's going on here yet, but hopefully by the end of the documentary you do. So that brings me to the next clip. Maybe, let's see if this one works. An error occurred. That's very good. That was not expected. Let me just see if I can refresh this quickly. If it doesn't, we will move on. Wrong one. Let's try this. There we go.
Quantum mechanics is, in some sense, the most successful theory ever developed. It can calculate something like the magnetic moment of an electron to 11 decimal places or more. I forget what it is, but it's something ridiculously high. Hard to calculate really complex things, but it appears for everything that we can calculate, it gets the right answer. And yet it has this sort of philosophical undercurrent, which bothered some people and doesn't bother others.
I think it's kind of a wild field to be introduced to, because you're always told it may or may not be something. So it's hard to kind of grasp the concepts when you're first introduced to it. It's hard to grasp the concepts when you've been doing it for decades. I hated it, to be honest.
I didn't get very much of quantum mechanics until my junior year of college. Threw some quantum vocabulary at us, but I found it sort of mysterious and honestly just kind of learned enough of it to get by on the exam, but it didn't really sink in.
There we go. That's a little intro when we start talking about quantum mechanics. We've got Eric Cornell there, we've got Bill Phillips there, starting to introduce people to the concepts and also acknowledging how hard it is. Harriet from Oxford Instruments Nanoscience, who got the unfortunate role of saying that she didn't really get it and she didn't even like it when she was first introduced to it. She did have words with me afterwards, after our screening initially, as to why that was her role in the documentary. No, I jest, but it's very useful to let people know that this is something very difficult, and it takes time to grapple with. I think before I move on to the next pillar, which is animation, I just wanted to open up. if we have any Discord questions, I'd be happy to answer those now. If not, we'll continue and go through in the next bit.
We don't really have any questions right now.
Okay, no problem. So next up, the animation pillar. And this was really key because as anyone who's studied this will know, trying to get a grasp of what quantum mechanics is and the various kind of concepts is often best explained visually. Certainly film is a visual medium. So whilst we can talk about stuff and have people saying things, it's better to try and show. The filmmaking rule is always show, don't tell.
Sorry, can you take questions? Like, I think we just got a question.
Of course, yeah. If we've got one, I would happily take it.
Yeah, thank you. It's a question from Megan from University of Michigan. Were there any concepts that you wanted to include but ultimately cut because they were too difficult to explain?
That's an excellent question. I wouldn't say there weren't concepts that we had to do to get rid of entirely. We did have to trim down our concepts. The way we actually structured it is not here in my presentation, but the way we structured it is that we had kind of we had 4 initial chapters, which were kind of short, roughly 5 minutes in each one. And we start off by introducing kind of wave particle duality, and then superposition, and then entanglement. And we did it in that order specifically because I believed that was kind of the more important way when it comes to understanding quantum computing. That was kind of a natural order to do it in. In wave particle duality, we had to cut. We had a great bit with Eric Cornell, but we had to cut quite a lot of that because, as many of you will know, that goes very, very deep. And we just found ourselves kind of lost in the weeds. So we actually, you will see it in this next clip. We allude to it. We go through some simple explanations, but we didn't go too deep on it. But the main concepts we tried to get across: wave particle duality, superposition, and entanglement.
Thank you. Question from Rashiraj: what hardships in a technical sense occurred for preparing the quantum mechanics documentary, and how did you overcome those?
Yeah, so I mean, the biggest hardships were we did a huge number of interviews. We had over 40 interviews, many of them over an hour. And, this is a complex topic. We had over 40 hours of this great interviews and great content, and cutting that down and editing it into something coherent that was credible was probably the hardest part of doing this. Because, you can spend a lot of time, as I said, lost in the weeds of trying to explain superposition, and you end up speaking at a kind of PhD level or beyond, which goes way over my head and goes way over most audience members' heads. So we had to be quite brutal with cutting that back. Aside from that, the other kind of big hardship is obviously, it's not really a hardship, but there's a lot of travel and time away on the road shooting something like this. We did multiple filming trips, a lot in the US, some in Europe. We had a separate Japan team. So there's a lot to coordinate there. And yeah, inevitably you end up spending a lot of time away and on the road. But that's just part and parcel of doing this.
Yeah, thank you. Thank you for giving us that insight.
Okay, no problem. Also, one other was the Japan team. We were lucky enough to get an interview with the CEO of Fujitsu. And we did that interview over Zoom, and the local team filmed it and sent us the footage. But it meant that it was kind of morning Japan time. So I woke up at something like 2 a.m. in the UK to quickly drink a coffee and do an interview on quantum mechanics with the CEO of Fujitsu, which in Japanese, actually, with an interpreter on the call, because he was speaking Japanese and I was speaking English. So that's quite mind-boggling on a few hours sleep. But we were very happy with the end result. But anyway, so I'll move on as an example of some of the animation that we did. And this is actually where we start tackling wave particle duality. So I'll come on to this next one. Hopefully this one will work.
In sort of the classical Newtonian picture of things, matter is composed of particles, and these particles can literally be anywhere and going in any direction, but in what we would call a deterministic way. Classic example is the pool ball rolling across the table towards a pocket. It's either heading towards the pocket or it ain't. If it's going to miss the pocket, it's going to bounce off that rail at a particular angle and another rail at a particular angle and either hit another particle or it won't. In quantum mechanics, these particles travel, whether they're pool balls or anything else, travel as waves. And waves spread out. Based inherently into the picture of quantum mechanics is an uncertainty. No matter how straight you hit it, It's going to spread out. It might go into the pocket. It might not. There's sort of this built-in uncertainty of things, which is sort of intrinsic to this wave vision of nature.
This uncertainty in the way nature operates, at its most fundamental level, had profound consequences for our understanding of reality.
One of the first things we learn when we're little children is the permanence of objects, whether we're looking at something or not. It's still there. I mean, this is one of the reasons why peekaboo is such a fascinating game for little babies. But we know that things exist whether we look at them or not. Well, that's not true when it comes to the subatomic world.
There you go. We've got had a little bit of a wave particle duality there, and then we got into Bill Phillips starting to get into superposition, which later had its own animated sequence as well. And yeah, I mean, Eric Cornell, for example, he had a great bit that went into a lot more depth on standing waves and discrete quantization and stuff. And it's just too much really for a general audience, especially in a film where you're trying to keep people engaged and get them to want to see the next thing and the next thing and move on to the next act, as it were. Going deep on wave particle duality tends to lose people. So those were the kind of editorial decisions that we had to make around things like that while trying to maintain a scientific credibility. I would say that, Eric Cornell was at one of our screenings that we did, and it's quite nerve-wracking having, Nobel laureate physicists watching your work, trying to explain concepts that their life's work is dedicated to. But he seemed very happy with it. So I'll take that. So yeah, the audience, a very important part of this documentary. We decided very early on that this was not going to be just another really quantum industry specific thing. This wasn't just going to be for academics. This wasn't just going to be for people in the industry. This was something which wanted to communicate to a wider audience. And we wanted to do that by telling the story in an interesting way. The documentary is skipped ahead. A documentary is it's a film, and film is entertainment, and so it has to entertain. It's not good enough to just do a 90-minute lecture on quantum computing for a general audience. So we were looking for story beats and things that would keep people engaged, things around the struggle of entrepreneurship in the documentary, the different companies, people who are betting it all on making the next quantum computer, the hardships and pushback that the initial founders of quantum mechanics faced, the disbelief that they faced, the things that they had to kind of push through to get quantum mechanics kind of taken seriously, and then also things like the potential upsides and downsides of technological advancement, which is a theme which runs throughout this as well. We'll speak more about that in a little bit, but yeah, that's the audience. Cast, this is some of our cast. Huge number of people, ranging. Sadly, not everyone, most of the people that you see here did make the final cut. Some people had to be cut for editorial reasons because there simply wasn't enough space. One of the big challenges is that when you've got 40 plus voices, you tend to lose a nice storytelling thread. We've got like Dr. Sato here from Fujitsu, Leslie Lee from Continuum. We've got people from Microsoft, Joe Boisho from Google, got Atom Computing. And we really wanted to kind of run the gamut here. We've got Airbus, and we've got quite a few other scientists as well. John Doyle, president of the American Physical Society. We wanted a pretty good range of people. We didn't want to just speak to industry. We didn't want to just speak to academics. They were important. The academics are generally our kind of storytellers and our explainers. Kind of industry people, our owners of companies or people at companies like Microsoft or Google, kind of we're explaining what they're actually doing and why they're doing it. So on a more practical level, and also trying to capture that sense of entrepreneurialism from the smaller companies, such as, Atom Computing, who tell the story of a founder, a company a few hundred people in size, compared to someone like a Google or a Microsoft who've got huge resources. And then, some government representation here. We've got Sir Peter Knight for the UK government. Not pictured here, but in the documentary, we also had a former CIA operative who was kind of a specialist in digital, digital espionage. And he was speaking about how intelligence gathering organizations such as the CIA and many others across the world are very, very interested in, firstly, digital dominance as a whole for achieving advantage over their geopolitical adversaries, and then specifically quantum because it means a lot of different things. I don't have a clip of this here, but for example, the CIA is very interested in quantum computing for a number of reasons. Advanced weapons simulations, intelligence gathering, and especially the one that we're all familiar with is decryption. And he spoke at length about that and the efforts which are currently ongoing and why geopolitical adversaries are kind of gearing up for this, which is happening. And the kind of global quantum arms race is one of our kind of themes and topics throughout this, because we're obviously looking for a way to insert some kind of competition, some interest here and make people, people's kind of ears prick up as it were, and think about kind of broader consequences of this. The example that the CIA operative gave was that, if a foreign adversary is developing an advanced weapons program or something that might be a threat to you, then it means that they have to go through planning and logistics, and they have to have meetings, they have to build test sites, and they have to launch, test launches and things like that. All of that can be picked up by, traditional intelligence gathering. But in theory, very high fidelity modeling systems that could be enabled by something like a fully scalable quantum computer could cut out a lot of that intelligence gathering, or that activity which is vulnerable to intelligence gathering. So a foreign adversary state, for example, can suddenly kind of appear with the weapon system or something that you haven't had a chance to notice or to prepare for. That was on the kind of the geopolitical arms race kind of weaponized side of things, and it's something that we wanted the audience to think about. Although I would say that is not the majority of the documentary. We just needed those different story beats in there to speak about, risks and opportunities and things like that. So yeah, themes: entrepreneurship, innovation and hope, ethics and risk. On ethics and risk, obviously the most obvious parallel, and we wanted to try and draw some technological parallels for people so they could get to grips with this. The most obvious parallel in some ways, it could be the invention of classical computing, but the thing is that comes out directly of the invention of the transistor, which comes directly out of the first quantum revolution. And the other thing which comes out of the first quantum revolution is nuclear weapons and nuclear energy. There's kind of quantum mechanics in some sense throughout its history is already linked to potentially either very dangerous or very powerful positive technological change that affects almost everyone on the planet. And that was something that we wanted to address, because we wanted people to feel that, this is not some abstract concept. This is something which, okay, I may not understand it deeply, and I may not necessarily interact with a quantum computer or something like that on a day-to-day basis, but in some sense, an understanding of quantum mechanics underpins, a lot of our digital technology that exists today. So it's kind of like a reason, like, oh, you're already using this. You're already using a phone with a microprocessor in it. Without the kind of advent of quantum mechanics, we wouldn't have those things. So it draws people in a way which, gives them something that they can understand and some kind of analogy for the development of the technology. Balanced alongside that, obviously, innovation and hope. We wanted this to be a human story that tells the story of people who, are risking a lot, who are spending their whole academic lives dedicated to furthering quantum science in some sense. That is something which has existed really for a very long time. I mean, throughout all of human history, humans have sought to innovate, to build new technologies, to overcome. And this leads to many great things. And for us, the ongoing development of quantum technologies is kind of one of the leading edges of that spirit today, and we wanted to get that across. So yeah, the story of innovation and hope in the face of adversity, taking on challenges and succeeding, which quantum is very much at the forefront of today. And I have another clip here, which kind of is a bit of the part of the film which kind of alludes to this balance.
Every new technology has consequences. And when quantum enables us to design materials much faster, much better than before, when it allows us to find new, better drugs, new, better chemicals that can be used for good or it can be used for bad. Chemistry and material science has always been dual use. In the Stone Age, rocks have been tools and rocks have been weapons.
Among the fruits of quantum mechanics in the 20th century, in addition to semiconductor electronics, which has changed our lives, I think, by and large, for the better, we've also had nuclear weapons, which are really dangerous and have the capability of destroying our lives. Neither of these were things that were being thought of by people like Schrödinger and Heisenberg. It raises the issue that I think every scientist thinks about. Will the things that I discover be things that will improve the lives of people, or will they be things that harm the lives of people?
So that I want to emphasize that is not the key thrust of the documentary, but we needed, like any film, you need a kind of narrative turn, as it were, and you need to present some level of challenge, risk, or threat, or something like that. And this is one of those things. Addressing the ethical implications of developing very advanced technologies is something which we are very keen to do in this film, because it's interesting, it's ethically relevant, and if, as I and many people in the industry hope, we do start to kind of fully realize the promise of quantum technologies, then it will have an impact on many people's lives and on society. And it can only be a good thing if people gain a deeper understanding of the technology, how it works, what it can be used for, because it's only by doing that that you gain the ability to kind of put democratic controls on it, things like that. But we are basically putting this out there so that people can kind of gain that broader understanding. Before I go into the final bit of the presentation here, I wanted to pause again and see if we had any more questions on what has come up so far.
Yeah, thank you. We have a few more questions. Question from Justin. Would you consider sharing the bloopers of some of the more complex topic explanations?
That's a good question. They might come out at some point. They're currently buried deep in a hard drive somewhere. But I mean, to be honest, yeah, there are some, and there are some funny moments. But the reality is that the scientists and the great people we had in it mostly were excellent at explaining it, and they explain it very, very well. Okay, sometimes they mess it up and they go, oh no, that's not right, I'll go back and do that again. Even Nobel Prize winning physicists sometimes make a mistake and have to go back and do it again. In general, they were very on it with successfully explaining concepts. We just had to be quite brutal with cutting it down, because, as I said, you just end up going down a rabbit hole that kind of distracts from the rest of the film. Watch this space, I would say.
Got it. Thank you. Yeah, there's a follow-up comment from Rishiraj on that technical bloopers might be a new perspective towards learning.
Yeah, absolutely. I mean, probably the funniest ones which we don't have would probably be me and the editor sitting in our office trying to work out how to do this, how to edit this together, and really stretching the capabilities of our academic backgrounds to get to grips with this.
Yeah, that would be great too. Question from Megan. So these themes are important and they apply to a lot of emerging technologies. How does looking at some of the themes that you mentioned through quantum change the way we think about these topics? Are there like subtopics that you think quantum expands on?
Yeah, that's a good question. Subtopics that quantum expands on, because yeah, I mean, it's very true. You could definitely say, I mean, those themes are generalist. They could equally apply to something like AI. I think one of the most interesting things, which may or may not apply to AI, it depends who you ask, but I think does apply to quantum, is that, and we do have some bits in the film which talk about this a little bit, which is that an evolving understanding of quantum mechanics, which could come out of improving our quantum technologies, is something which could fundamentally change the way that we understand that our world works in a way which something like, I mean, AI, the jury is a little bit out on that. You definitely get schools of thought that think that an artificial general intelligence kind of super AI would be able to reveal to us the secrets of the universe or something, maybe, I don't know. That's not entirely clear to me that that's true of AI. It might be. It can certainly analyze extremely large data sets in ways that we can't. Quantum mechanics and quantum technologies, you're actually dealing with something much more fundamental, which is a deeper understanding of the real physical reality of how our world works. And it's true, I think, to say that there are things within quantum mechanics that we simply do not currently fully understand how they work. We have, maths and equations and explanations for them, but there are things which defy some explanation at a human level. And it might be that we never gain an understanding of those. But in the case of quantum technologies, it's possible that we enhance that understanding. So the difference to me is, yes, ethics and risk and use of technologies is something which is true of any advanced technology or new technology. But this is something which is, when it comes to quantum, this is something which is rooted in the reality of how our universe works. We know that to be true. So it's possible that a deeper understanding of the physical reality of our universe leads to things which we simply cannot understand currently. And it opens a door to more unknown unknowns, I think, is a way of putting that. It's quite a long-winded answer, but hopefully that makes sense.
Yeah, no, that makes a lot of sense. Yeah, thank you. Question from Dhanalakshmi. Something that was mentioned in your slide. And it's basically like, were you able to get some insights, kind of talking to all these experts and in these different fields, and on how to identify whether a challenge is like a temporary engineering problem or like a fundamental limitation of nature? And with quantum computing, which current limitation do you think would be most likely be solved?
Yeah, that's a very good question. I mean, I don't have I'm not sure anyone has a deep understanding of certainly no one that we spoke to claimed to have a deep understanding of which challenges are kind of physically just impossible and which are just an engineering problem. I mean, people have ideas. Obviously, over the last couple of years, and even while we were making the documentary, the error correction kind of challenge has been not solved, but significant strides have been made in improving error correction, quantum error correction, which we speak about in the documentary. So that looks like it's something which could be solvable. And again, the other people from Microsoft speak about this, is that we can make qubits, and we can make pretty good qubits, it seems. Some companies' claims are different to others. We do have a section on different people claiming different things, which is quite funny, but it seems that we can definitely make good qubits. But possibly it's a big engineering challenge to make maybe 1 million of them. If you need 10,000 logical qubits, it's very difficult to then make 1 million physical qubits. Or maybe you can make 1 million physical qubits, but now you've got to control them. So that seems like a very big engineering challenge, but not a fundamental physics challenge in itself. I don't know, in terms of fundamental physics challenges, it probably the place to look, my sense would be that if it's something which even in like quantum mechanics theory, which we are still kind of scratching our heads over, things around entanglement may prove to be things that we are that are simply beyond our physical comprehension. I don't know our ability to use. That's not clear. There is an open question there. And several people in the documentary, or not in the documentary itself, but when we spoke to several of the scientists, several were pretty open about the fact that it's possible that a fully scaled quantum computer is not going to be achievable. They don't necessarily think that's going to be the case, but they accept that there are limitations. There are engineering limitations on what we can control and keep cool. There are limitations on what we can understand and control about entanglement. We don't understand fully how it works. So can we use it? I don't know. Bill Phillips, for example, this is in the documentary. He has a bet going with a fellow scientist where, the bet is, will we have, a functional quantum computer that can factor a sufficiently large number by the year 2050 that a classical computer cannot do. And I don't know which side of the bet Bill Phillips is on, but one of them thinks, no, that's not possible. And the other thinks, yes, it is possible. And depending on who you ask, some people say, yeah, we're going to be able to do that in 2 years. Far be it from me to say who is right. I actually have no idea, but it is a significant number of engineers and scientists do accept the possibility that it could be impossible, at least on a reasonable time horizon. In terms of how you identify which problem is which, that's a question that's probably above my pay grade.
Oh, no, thank you for that answer. We have more questions? Do you want to have them at the end, or do you want to do one more question?
Don't I just I'll quickly. There's not much left of the presentation here. I'll quickly go through this, and then we'll do the remainder of the time with questions.
Okay, sounds good. Thank you.
Okay. So continuing on, some behind the scenes shots here, just giving a sense of the kind of production we did. I think probably about 6 weeks overall in the US in a couple of different trips. We did Airbus in Hamburg in Germany. You know, this is kind of what a very lightweight production looks like on the road. You see here bags of kit and lights, very lightweight production for something that is, if I do say so myself, pretty high production value. But we had to be very lightweight. We had to work out traveling with a lot of equipment, hiring local gear, and, you know, dealing with this with a very minimal crew. You can see a few of our different interview setups here. You know, in front of the Microsoft Seattle, Washington clean room that they've got there. That was a lovely location. Professor John Doyle's office here at Harvard with his blackboard in the background. It was a lot of fun. So yeah, a few behind the scenes kind of snaps, as it were. And then, yeah, the future, a couple of shots from our London BAFTA screening. Elias Khan here was a supporter of the documentary from early on, of Continuum. He's featured in the documentary as well. So where are we at now with film? So, I mean, I guess if I just go back here, we've done screening in Boulder in Colorado, which a lot of people featured in the documentary were in Boulder in Colorado, obviously being a hub of technology innovation in the US. In terms of the future of the film, where we're at today is we have signed with a global distribution agent whose job is to sell it to media purchases the world over. We have had a couple of small sales. So, for instance, I believe a version of the documentary will be available on Belgian TV. Very interesting. And I think we have a UAE purchase as well. But the way that film distribution works is you can, unless someone goes and buys like a big global license, which pretty much never happens, the different organizations buy it for a different license in a different region. So you could have someone might buy it for TV in Belgium, and then someone buys it for online streaming in the UK, and so on and so forth. You can sell the same thing multiple times as long as their kind of licenses don't overlap, as it were, so they're not competing with each other. But obviously for us, the big one that we would very much like would be one of the major streaming platforms, ideally with a US or European market coverage. But that is ongoing, but fingers crossed. It's been with the distribution agents for a couple of months now. For us now, we're in the process of kind of film festival submission season, looking to try and get into selection for film festivals, which will happen late this year, which really help raise the profile of the documentary and the topic. But those are all pending decisions right now. And then, yeah, I mean, the future, I wrote a little bit on quantum technologies here, but the reality is, I mean, many of you will probably know better where quantum technologies are heading right now with a technical background. But it certainly feels like a potential inflection point is coming in the industry. That's the sense that I got from speaking to a lot of these people. Obviously, in the industrial sense, everyone's waiting for a real proof of quantum advantage in an industrially useful application that either cannot be solved or cannot easily be solved by classical computers. And there have been a lot of announcements recently, a few IPOs like Continuum. It certainly feels like that is very close. And I think the error correction issues for quantum computers starting to be really successfully addressed over the last couple of years takes us some way there. You know, the truth is that very large companies and states across the world are pouring significant resources into this, and they're taking it very seriously. And so our thought was, well, then people should too. So now is the time for the general audience to become more aware of it. So yeah, that pretty much wraps us up for my presentation. So thank you very much for listening, and I would happily take any more questions.
Yeah, thank you. Thank you so much for this wonderful presentation. We do have some more questions. Gonna go through them. I don't think we'll have time to go through all of them, but we'll do our best. A question from Justin. So quantum phenomena is often counterintuitive, right? And you can't really directly observe it. Then how do you decide where science should guide like the image and the graphic artist interpretation, where that should take over to ensuring that there are no misconceptions made about quantum physics? And how did you tackle this, and what advice would you give to someone trying to create content about quantum when they don't really have noble law that's guiding them?
Yeah, that's a very good question. I mean, so we made those decisions based off, we had a couple of designers and animators working on this, and I worked very closely with them, and we had an idea of the visual style and kind of general look and feel that we wanted, and that was our guiding light in terms of how things looked. And we had to accept that there were moments when it had to be kind of style or visual over like perfect accuracy to the science. There's no hard and fast rule, certainly for us, there wasn't, for determining exactly which should be which. We simply tried to stay away from overly stereotypical pitfalls that it's possible to fall into. In terms of recommendations for if someone was trying to communicate quantum and visualize it in general, depends on your audience and depends on the platform that you're speaking on. But if you're trying to teach, it doesn't need to be fancy. We obviously put a lot of time and effort into trying to make these look good, because it's a film, it's entertainment, people have to enjoy watching it, but you don't have to go the whole 9 yards, as it were, when trying to explain a concept more simply. Some of the best explanations that I've seen when I've been searching, trying to get my own understanding, have been much more graphically simple. We also actually took some inspiration we actually looked up from our like Nobel laureates, publicly available papers, diagrams, things that are in their papers, and to draw inspiration from those as well, to make sure that we're firstly trying to stay true mostly to the science and also gain some kind of visual reference. So like Alana Spey's entanglement experiment, for example, is actually in the documentary in kind of a graphical form.
Thank you. Question from Animesh. But I'm kind of going to paraphrase. It's a long question. So you did mention that like in your interactions with all these scientists that you spoke to, that kind of people had like different perspectives, right? Like on like, where the quantum advantage may lie, what different types of qubits and what benefits they may pose. And, you see a lot of quantum computing companies that are all like, I'm sure like everyone has their own goals and like what they think would be the first application that would benefit from quantum technology, things like that. When you kind of have all these like different perspectives like playing out, do you kind of see this as kind of like is this like a very disorganized? Like, do you have any thoughts on how do we kind of address that and how do we make it more mainstream and more uniform in kind of the approach, I'd say?
Yeah, that's a good question. At this stage, I don't think there needs to be a concerted effort to try and make that more uniform. I think trusting the market in a way to do its thing, let the chips land where they will land, and there will be winners and losers. And it will naturally become efficient through that process. Some modalities may not work, in which case those companies are not going to sell many quantum computers and they will be acquired or die out. And others will. No one knows exactly which is which. I don't think there should be an active effort to try and trim down or mainstream everything at this stage, because you risk cutting off and killing something which is otherwise potentially very promising but is not advanced right yet. I think the most credible take on this in general in terms of modalities was several people were, even a couple of credible people from companies who have their own skin in the game. Okay, some companies were ours is definitely the best way of doing it and no one else comes close. I won't mention any names, but there are definitely some people who act like that. I'm not sure how believable that is. But the most credible takes on it, I felt, were people who said, we're not entirely sure if this modality will eventually work or be the best, but a very likely outcome is different modalities work very well for different things. It's a mistake to try and fully map on the digital computing semiconductor revolution onto quantum computing, where we basically just ended up with silicon and TSMC. That's not necessarily going to be the same way that it happens with quantum. There could be multiple modalities and multiple companies which serve different modalities that are better for different things. That seemed credible to me.
No, thank you. Yeah, I agree with that. Question from Adi on do you think we'll ever achieve on having a movable quantum computer, like something that you can carry around in your pocket?
I mean, never say never. Currently, looking at the facilities that we're in, looking at these machines, currently it seems unlikely, and the near-term proposed uses of quantum computers don't really have, real pocket-sized use is probably not something which is necessary currently. Okay, people said that about computers in the 50s. It's possible that that's wrong, but if it is the case, if that does become the case, it's a huge engineering challenge to overcome and won't be for a very long time, if you ask me.
Yeah, no, I agree with that. I think they, it needs to be cooled down and kept away from noise and environmental disturbances. So I think it would be very unlikely to have something like a mobile sized.
Yeah, I mean, mobile in terms of, that an average person would use, I can definitely see if you go to the geopolitical state level, if you're trying to do very advanced modeling or analysis in, I don't know, a battlefield scenario, you could have some kind of mobile system which was a bit bigger but still mobile, that could work locally on something. But even that's we're talking about a very long way away and may or may not happen.
Yeah. Thank you. Maybe we're running out of time. Maybe we'll take one last question. A question from Sanjit. So out of all the people that you interacted with, which on or off-screen interaction significantly influenced your understanding and hope for quantum technologies?
Great question. Yeah. Well, I mean, a couple of people stand out to me, and that's Bill Phillips, firstly, because he is a fantastic communicator. He's got a great voice for being on camera, and he's very, despite spending so much of his life working on this, he's very generous with his time, very, very good communicator, very good at communicating at a basic level for people to understand. So that certainly helped my understanding of certain concepts. And the other person is Alana Spey, is a very interesting character, very, very French, which is very fun, lots of character. But it took me quite a while to get to grips with his explanation of entanglement. But I found it very instructive after I had replayed it several times. And Alana Spey also really pointed out the link between entanglement and then the ability to build larger network systems that really unlocks the potential of quantum computing. So that probably gave me the most hope or interest for the future.
Thank you. Maybe one more question on if people can attend some of these private screenings that you have coming up, and would the documentary be available for educators who wish to share this with their students?
Yeah, so we currently don't have any other screenings planned, although it is possible. We have to be slightly careful because we can't, we obviously have a distribution agent and there are certain deals, and we can't get into like certain film festivals if we've already made it publicly available in certain areas and stuff like that. So we have to be kind of walk a bit of a tightrope currently on that. But that's not to say that there won't be private screenings in the future, and it certainly could be available to educators in the future. Right now, we're trying to see where the lay of the land is in terms of who's buying it, what festivals want it, because they all kind of have different rules about like, oh, it must be a global premiere or something like that. So we wouldn't want to make it available and then realize that we'd shot ourselves in the foot, as it were, and now couldn't show it at a really good festival. But I'm sure that in the future, it will be available as an educational resource.
Thank you. Yeah, no, that makes sense. And yeah, I hope it's available. It'd be interesting to watch the full feature. Well, thank you so much for taking your time and like coming and sharing this very, very insightful talk and like a really fun presentation. I really appreciate it. And, I think it's really important for like some of our participants, who are like very kind of technically strong, but it also shows them kind of the importance of communicating some of these ideas and like presenting it in a way that like, everyone understands. And thank you so much for taking your time to do this with us.
Thank you very much. It was a pleasure to be here. Hopefully coming to a Netflix near you soon. Fingers crossed.
Yeah. Thank you.
Okay, thank you.